Teach you about how to calculate the blending percentage for each sieve size and compare to design JMF limits. And I will also teach you how to calculate the batching weights for your production of asphalt. Let's start.
During the production of asphalt, weights for batching, stockpiles of all aggregates, cold beans, temperature of aggregates, temperature of bitumen, mixing, timing, and selection of trucks.
Consult the latest report of sieve analysis. Select all the passing percentage for each size of aggregates: 1.5 inch, 1 inch, 3/4 inch, half inch, 3/8 inch, crushed sand, and filler. Consult the sieve analysis reports. For example, here 1.5 inch, select passing percentage from here. Similarly, the aggregate size 1 inch, select passing percentage from here, and 3/4 from here, and select the passing percentage of aggregate half inch, and select the passing percentage of aggregate 3/8 inch. Select the passing percentage from the test report for sand, and select passing percentage for the filler. Now make on your computer an Excel sheet. Write all aggregate sizes on left column. Write all sieve sizes on the top. Then put the passing percentage of all aggregates one by one. For example, here passing percentage of 1.5 inch. Then put the values for passing percentage of 1 inch, 3/4 inch, half inch, 3/8 inch, sand, and filler. Consult the design and select the percentage required for all aggregates individually. Here is an example of design percentage for base course class A. Aggregate size 1.5 inch is required 30%. 1 inch is required. Here no requirement for 1 inch in this design. 3/4 inch required 10%, half inch is required 10%, 3/8 10%, sand is required 35%, filler is required 5%, so total should be 100 by weight of aggregate. Now you put the values of percentage in one column and multiply all the percentage passing with this individual percentage. For example, 1.5 inch aggregate, all passing percentage of 1.5 inch aggregate is multiplied by 0.30 because 1.5 inch is required 30%. Similarly, all other aggregates, 3/4 inch is multiplied by 0.10 because it is required 10%. And half inch, all passing percentage will be multiplied by 0.10 because half inch aggregate is also required as 10%. And passing percentage of 3/8 inch is also multiplied by 0.10 because it also required 10%. And now sand is required 35%, so all passing percentage will be multiplied by 0.35, and filler is required 0.05%, and all passing percent will be multiplied by 0.05. So now this percentage, individual percentage, will be multiplied and all values will be changed into new values. Now you can add from top to down to calculate the value percent for blending. As you can see, the sieve size 1.5 inch giving here blending value as 100, and the sieve size 1 inch is giving blending percentage value as 84. Similarly, you can calculate all the sieve blending values. Now consult the design and put the values for design JMF and compare all your blending percentage values with the design JMF values. As you can see here, the first force is giving the exact value as design JMF value, but the sieve number 38 is giving as 53 blending percentage value, but 53 is inside the JMF limit because our design JMF limit is 52 plus minus 5. It means 47 up to 57. So 53 value is also correct. So you can calculate the blending percentage and match with the design JMF one by one. All your calculated blending percentage should be inside the design JMF limits. Now calculate the weights for batching. Consult the approved design and select the weight of bitumen within the limit of approved design. Here is an example. 5.2 plus minus 0.4% is the design limit for bitumen. It means you can select any value 4.8 to 5.6. Example, I am selecting here 5.4%, which means 54 kg bitumen in 1000 kg, which is 1 ton. Consult the approved design and select the weight for sulfur. It is recommended 30% of sulfur by weight of bitumen. If bitumen is 54 kg, then 30% of 54 is 16 kg. So bitumen is 38 kg, which is 70%, and sulfur is 16 kg, which is 30%. So total is 54 kg. Subtract the 54 kg from 1000 kg, which will be equal to 946 kg, is the weight of all combined aggregates. Write aggregate size in one column and write percent used for aggregates in another column. Now calculate the weights of aggregates one by one. Here is example. 1.5 inch is used as 30%. We have to calculate 30% of 946 because our total aggregate is 946 kg after subtracting the weight of bitumen. So it will give the value of 284 kg. Same as calculate the weight for 3-4 inch aggregate, half inch aggregate, 3-8 inch aggregate, sand and filler. Now you have calculated all the weights in kg. Now inside the control room, the operator system put all these values one by one. Select stockpiles of aggregates. All stockpiles should be uniformly mixed, otherwise it will not give a uniform mix. All stockpiles should be at a distance of 3 meters so the loader can move easily and aggregate of one stockpile not mixed to other stockpile. Stockpiles should be free of clay material. Stockpiles should be in dry condition. Move the material one by one in cold bins. There should be separate cold bins for all aggregates. Avoid mixing one bin material to other bin material. Ensure that all cold bins discharge gate is working and aggregate from each bin is transferred to belt properly. Move the aggregate from cold bins to dryer. Here note the temperature of all aggregates. Aggregate temperature let to be as 145 centigrade. Then you check the temperature of bitumen. You can check the bitumen temperature from the gauge with bitumen tank, or you can check directly from the operating system. Then you select the mixing timing. Select mixing timing as 30 seconds. Before starting the mixing, ensure that mixing unit is clean from inside and there is no hardened asphalt inside the mixing unit and discharge unit downside. Selection of trucks. All trucks should be cleaned by diesel and there should not harden asphalt inside the truck. All extra diesel should be removed over the truck. All trucks should have tarpaulin to cover the asphalt after loading. Mix 2 tons of asphalt and discharge in the truck. Then check visually. If asphalt is good, then continue your production. If asphalt is not good, like uncoated or looking fine or looking coarse, then you can make new adjustments. You can increase or decrease the percentage of aggregates. You can increase or decrease the weight of bitumen. Here is an example that asphalt is looking uncoated and looking fine. So we have to increase the bitumen and we have to decrease the fine aggregate. Look at the previous percentage. We were using filler as 5% and sand as 35%. Now we have to reduce the filler by 1%, that is from 5% to 4%. And if we decrease the filler 1%, then we have to increase 1% by any other aggregate. So we increase the sand 1%, so the total should remain the 100. So sand before 35%, now it is as 36%. If your blend values are inside the design JMF values, then your selected percentage is correct and you can further calculate the batch weights. Now calculate the weights by new percentage and put all these new weights values in operating system again. Mix again 2 tons and discharge in the truck. Then check visually. If asphalt mix is good, then continue your production and wait until the truck is fully loaded. After the truck loaded, stop the truck at sampling point. Take samples according to Aramco standard for extraction, sieve analysis and Marshall properties. After testing in the laboratory, review report for extraction and sieve analysis according to Aramco standard. Review the report for Marshall properties according to Aramco standard.